Okay, here is some information about doing the resistor lab. And what we're going to do is build this circuit here. I'm going to show you how to do that with the parts in your kit. This is the battery, this represents the light bulb, and this is the variable resistor or the potentiometer. So here are the parts. The light bulb is this teeny little bulb, the potentiometer, and the battery. So how do we connect them together? Well, in the previous videos you saw me stripping wires and stuff. One thing that's going to be useful in this lab is to you have a red and a black wire, and if we attach alligator clips to them, that'll make it easier to connect them to this variable resistor. So what I'm going to show you really quickly, got an alligator clip, there's a screw on top, and so I stripped my wire about that much, and I'm going to poke it through the cameras. There we go. I'm going to poke it through the end of this thing. You don't have to, you could just do it directly on there, but it's kind of fancier to poke it through the end. And if you can get it to come out there like so, there we go, comes out there. Poke it through some more, and I'm going to take a screwdriver. Come on, focus. And I'm going to loosen this screw on here so there's enough room, and then I'm going to take my wire, the stripped end of the wire, and I'm going to fold it into a little hook so that it's all the way underneath that screw. And then once you get it in there nice and secure, you can tighten it down. And now I have a alligator clip on my red wire, and I've already done that on my black wire. So I have these two clips, and the other ends of these wires I'm just having them be bare wires so I can twist them to things. Okay, so that with those parts I should be able to build this circuit. So let's see. I'm going to take my battery clip, and right now I'm not going to worry about which part goes to positive and which negative, and you'll see that it's not as important as when we had capacitors. First thing I'm going to do is going to connect one end to the light bulb. So they're both just bare wires. So I'm just going to twist them together a couple of times so they make a decent connection. And again, when you're twisting things together, my advice is to have them sort of separated out like a Y, not sort of close together, but make them bent out like that, and then take that Y and just twist it a couple of times. You don't have to twist it forever because it's hard to get apart. Okay, now I'm connected to that. And then I want to connect the other end of my battery. So I went battery to light bulb. Now I want to go light bulb to the potentiometer. And so I'm going to take say my black wire and connect it to. And why am I using the black wire? Because I'm trying to just keep the red and black is just for your own bookkeeping, it's just for your own organizational. So I'm going to use the red wire with the red and the black wire with the black, and even though it's gone through the light bulb, it's just to help you to keep track of which end is the uphill side of the circuit and which end is the downhill side of the circuit. I'm going to connect my wire to this one, and one of them's stiffer and one of them's thinner, so it's a little bit tricky to twist them up, but with some practice you'll get used to it. Twist them a couple of times. There's a nice connection. Now I'm going to connect that end to my potentiometer. Right now I'm just going to go with the first one. Okay, so there's my connection. And then the circuit diagram says the other end of the potentiometer goes back to the battery. So now I'm going to use my other alligator clip, and I'm going to go to the middle one just for now. And then back to the battery. I have two bare wires. I'm going to twist them together. Okay, now I have a circuit. It's very long, lots of wires. You could cut these wires, there's definitely no need for using these whole wires. I just gave you lengths of wire so you'd have enough to make multiple wires. So probably easier actually if you cut these in half or something, and you'll have 4 wires instead of 2 wires, and they won't be all over the place. But for now, we have this. And how many lanes are there in our circuit, right? This is a series. We call it a series circuit if there's only one lane of traffic, and a parallel circuit if there are multiple lanes of traffic. So I'm going to follow from the red wire. I go from out of the batteries through the red wire, through my resistor, and then through the light bulb and back to the battery. So that's what I have here, just one. It's a lot bigger, but it's one circuit. Okay, and now the lab asks you to measure the voltage across the light bulb as you change the resistor. For the heck of it, I'm just going to measure the voltage across the battery first, just to check that my batteries are charged up, and just to have a starting point. It's always good to double check things to make sure, like what if you're dead batteries and then you spend all this time doing the lab and you don't get anything. So just for the heck of it, I'm going to take my black and red leads, I'm going to put them right across the battery, which means one on the red and one on the black before I get to any circuit parts. And my multimeter says 2.57 ohms, which these are rechargeable batteries. They'll be slightly different than if you have non-rechargeable batteries, but that looks about like what I expected, so it looks like things are good. And now the lab says, let's look at the voltage across the light bulb. Before we do that, let's just play with the light bulb. What if I adjust this resistor by turning the knob and seeing if that has any effect? Oh, look, the light bulb goes on, and I turn the resistor, I'm turning this knob, and it goes off. So I can turn that on and off. It's not just a switch, it's going dimmer and dimmer. It's like a dimmer switch. So that's cool. I made a little dimmer switch. So you can study that more carefully by putting your voltmeter right across the light bulb and saying, well, what's going on with that light bulb? What are the volts across that light bulb? And now I can turn my knob, and I can see that the numbers on the voltmeter change. So that's one of the things you're going to do, is play with that, see how that affects it. And you can also, now I can ask the question, okay, say I get a certain voltage across my light bulb. There's a voltage across my light bulb. What is going to be the voltage across? So I'm measuring the voltage across the light bulb. What's going to be a voltage across my resistor if I have a certain voltage across the light bulb? To answer that question, you can just take your 2 probes and put them right across the resistor. You'll want to put them in the same terminals that you connected to already. So one way to do it would just be to clip these alligator clips onto the other alligator clips, just like that. And then you can measure the voltage measure the voltage from here to here, and compare that with the voltage from there to there, and you could compare that with the voltage across the battery, right? You can measure all these different voltages. Okay? And you can also see how that changes when you turn the knob. Okay? And the other thing it's going to ask you to do in the lab is to measure current, and we talked about in the lab meeting how measuring current is harder because I cannot just now take these 2 probes and touch them across 2 different things. I have to break open the circuit. So in my diagram here, I want to measure current somewhere. I have to put the ammeter inside the lane, not make a new lane. So I'm going to say break open the lane there, break open the circuit, and put my ammeter right in the circuit so that it measures the current going through it, not across it. So let's do what I just drew. Let's see if I can, how do I connect that I just drew, an ammeter in the circuit? So what that says is, instead of now coming from the battery to the light bulb, going from the battery in excuse me, I'm going from the battery into the ammeter, then out the other side of the ammeter, and then into the light bulb. So first we have to reconfigure the meter. So now instead of being a voltmeter, we want it to be an ammeter. And we'll turn it to the ammeter setting, but we have to think about what kind of amps are we going to measure, AC or DC. We know we have a battery, so that's DC. And then it's got several different ranges. That one says amps, that one says milliamps, and that one says microamps. And you will get, as you get more experience, you'll predict which ones are the best range for your situation. But right now I'm going to put it on milliamps because I think that's the best one. And we also have to change these leads. Right, the black one always goes in common for all measurements that you'll be doing on this multimeter, but the red one goes in the jack depending on what you're measuring. So here we have the 10 amp jack is if we were on the amp setting. The milliamp and microamp settings use this jack, and the volts and ohms and stuff use that jack. So we want to measure milliamps. It's a lot easier if you have two of these meters. In fact, if you have a lab partner that you are not social distancing from, this is probably rare, but if you do, you can combine your efforts and make one of these a voltmeter and one of these an ammeter and use them both at the same time, and then you don't have to keep reconfiguring them. Or if you happen to have a friend with a multimeter, or you happen to have another multimeter, it doesn't matter that they're the exact same kind or anything, you can do that. Okay, so now I've got this set up to measure current. I have to break the circuit. I can't just go across. And in my diagram, I decided to break the circuit between the battery and the light bulb. So where is that? That's right here between the battery and the light bulb. So I'm going to untwist that. And now it's going to go into my ammeter, out my ammeter, and then to the light bulb. So into my ammeter, I'm going to say that's the black one, going into my ammeter. So that goes in, comes out of the ammeter is my red one. So I can write on here if I want to. This is like the black coming in and the red going out. If you want to, that's not a real circuit diagram thing. I'm just saying that for purposes here. And then that red one coming out is now going to go to my light bulb. So here's my red coming out, and now I'm going to go to my light bulb. And the light bulb should still light up, depending on if I have this setting. And yep, you can still see it's lighting up. And now you can see the current meter is measuring DC milliamps. So I'm getting it to be about 84 milliamps, the maximum brightness. Okay, and a question in the lab is going to ask you, what do you think is going to happen to the current if I put the current meter here versus somewhere else in the circuit? What if I instead break the circuit here and put the current meter there? What reading do I expect for the current meter here compared to when I had it there, or say here? And to do that, you'll have to open your circuit at different places and put the meter in that place. Okay, so we're going to be looking at, and you can also look at, say, well, what's the current? How's the current going to change if I dial this resistor up and down? That's what we're going to be looking at: current, voltage in the circuit, and using the meter. Okay, so hope you have fun and learn stuff. I hope you learn things also that we didn't even ask you to learn. Always take advantage of these situations to ask your own questions and test them out. Okay, let us know if you have any questions.